Okay, so and there is a lot of, just to make you aware, there's a lot of data. I'm sorry, there's a lot of tutorials on the Microsoft site to help you learn these new versions, and actually the old versions. So for instance, if you're still in a world where you're using Office 2010, and by the way, Office 365 is free to you now.
Right.
You all realize that it's free.
It can't be.
And they have a version for the Mac.
Right.
Have
got it.
You've got it, okay, cool.
And is it, it's exactly the same
As what?
as the Microsoft Word that would work on a regular PC rather than a Mac?
I don't know.
No, it's not quite, because I've played with it, and it isn't exactly the same. It's
Okay.
close. So.
Like I've been trying to do some of the things that are up on his list, and some of them don't work.
Yeah, they
don't.
Yeah, some do.
Some do.
If the
There's-
imaging it doesn't work on Mac.
There's, and actually, there's so many Mac users, I really need to get with the program and figure that out, because I think there are keystroke combinations that will do it. I just don't remember
Yes.
what all they are, so.
Because I went in to see an Apple Genius, and he was moving around by using the keys.
Okay.
And not the
I'm
mouse.
sure there's a website.
But the other thing is, I would say, if you're going to buy a new laptop, I'd make sure it's touchscreen, because that's the other thing is, I mean, yes, you have to reach out and touch it, but the point is you don't have to remember all those keystrokes. Because there's a concept, I think we talked about this, called intellectual overhead. You're saying to a nurse, look, I need you to use this electronic system, and by the way, you better not forget about whatever you need to take care of that patient. And so the nurses would say to me, now I have two patients, because I have to nurse this stupid computer, and I have to nurse my patients.
Right.
It isn't fair. It shouldn't be that way, but it is. So there's a lot of intellectual overhead. So I think as we move more and more into touch screens, and of course originally they were fairly expensive, now they've come way down in price. So, okay, here's a number of websites and actually the Google search tips thing. You know, and some of you may be Bingers, if anybody, or you guys big Bingers. I don't like Bing as well, but it's just, you know what it is? I think in all fairness, it's because what I'm used to. I like, I know how to do Google,
I know how to do
you know,
it. Yeah.
so. Okay, now let's just mention this, and we'll talk about it. We'll talk in a couple seconds about, we've already talked about this. There's Jerry. So did you meet with the visitors?
Yes, we did.
You must have had 2 or 3 lunches then, huh?
Just 1.5. But there's a couple other people come in. But it was very beneficial, I think, for us all. I'll just sit back here that way.
So here's the thing. Think about this. In times gone by, you installed an application on a server. And so then you had this, what we call the client machine. That's the client server environment. Okay? That's client server. But here's the thing. On that server, you had to install whatever the application was. And then multiple people could access it. And that's all fine, well and good. But in addition to that, is that for me?
That's for
You
you.
are so sweet.
You said not to come back without a sandwich.
All right. You get an egg. No, just kidding. So, Jerry, you can sit here, dude.
Oh, my bad.
Back there.
Sorry.
That way I can slap you up the head if you slow down.
That's happened
After that big lunch.
That's happened before, too, yeah.
Okay. So we were talking about the kind of computer environment that we're already moving towards. And so the point is that you generally, in the client server world, you had a server that was off in a box somewhere downstairs, God knows where. And then the clinical users had a computer there and they could access that. What that also meant, though, in a lot of cases, was there was applications that had to be installed on this box. So what we have now is what we call virtual or cloud computing, the next wave. And what that simply means is this. You have to install an application that talks to the cloud, but that's it. And so all of the processing is downstairs somewhere, God knows where, on some big server farm. And none of the processing happens at the local client level. The beauty of that is that when you have these laptops, although there are plenty of space on them now, I mean their RAM is incredibly cheap, and so there's plenty of space. You don't have to do that. You don't have to install other than this virtual client, we call it. And what that simply means is actually what's happening is this. All of the processing, all of the patient lookups, all of the things about don't give this med because the patient's allergic, all of that AI stuff, all artificial intelligence stuff, is all done at the server level, and all that the nurse gets at the bedside is literally a video image. It's all done at the bedside. Now, how in the world do we do that? Because think about this. When we're using these systems, we have to think about pipe space, how much pipe space we have. Because when you think about all I'm doing is sending video images tend to be the largest piece of any given file. But here's the thing. With the new virtual systems, if the whole patient record, and this is not a patient record, but if the whole patient record was the same, except I changed one little piece of information, what the virtual systems do is divide it up into quadrants, and then could be 16 quadrants, whatever, which isn't a quadrant, but 16 places. And I only have to replace that particular part of the screen where the image has changed. So I am not resending this whole great big image every time. So that's part of this whole paradigm of virtual computing. The other thing that's nice is that no patient data is stored on this local machine. None. So if somebody walks in, which they do, and steals that thing, one downtime I was working on a Saturday, and so the doc's room was open, and some family member walked in there and took a little cube, our little downtime, or our thin client, we call it thin client. And I thought, well, you're going to get home and plug that in, buddy, and it ain't going to do a damn thing for you because that's not the way it works. It's a whole different paradigm. Really, all that was in that little box was a video card. Because that's all you really needed. It just would process all this quadrant information and ship it to the screen, and you're done. And the clinician didn't have to put in, and if they sent any patient data, if they put it in, it immediately went to the server, to the database, and it never had to be processed at the local level. So pretty...
Probably would be a way also for Macs and PCs to talk to each other. If you're saving them in the cloud also.
Well, that's right. You shouldn't. So that's a good question. If you're saving stuff to the cloud,
Yeah.
then all the data is in the cloud. So that way, it shouldn't matter if you can have a Mac front end or a
Right.
PC front end.
Right.
It shouldn't matter at all. So.
And now they're kind of interchangeable. You can run Word stuff on an iMac, I think, now. I don't know how that's done, but
Well, they're just using the Mac OS. Because for a long time, they had a piece of software called Parallel, where you could have a Windows operating system and a Mac operating system. And all the time, I used to run around making money installing that for my clinicians at home. That's silly. We shouldn't be doing that. It should run in a Windows or a Mac environment. Come on. But now I think we're pretty much at that point. The virtual client will run on the Mac. They have it built for the Mac. You can install it, and again, all you're getting is whatever piece of the visual of the image that I need to make the screen full, and that's it. I don't have any real data that's anywhere near where anybody can steal it, whatever. So very, very useful from a security standpoint.
Google Docs, you got all the Microsoft productivity right there.
Yeah, you do. Actually, that's a different issue, but yeah, that's another. So anyway, one of the tools is called Citrix. It's by a company called Citrix. They're just one. There's a number of other very good companies. Certainly Microsoft has a version of that. Citrix, though, has a big contract with the U.S. government. And this is almost exclusively what the government uses, is Citrix. But again, see, and I somewhere on one of my slides you'll see it. It said, don't deploy what you can't support. And so we've used it a long time. It's fairly cheap. I don't know what the cost is, millions, but anyway, it's fairly cheap. And we know how to deploy it. It works. So, all right. Oh, now, we really need to stop for a second. Okay, so let's sail on.
Yes.
We have way more information than I'll ever possibly have time for. We'll talk a little bit more about cloud computing. So one of the things you'll see a lot now is they use SAS or SaaS, software as a service. That's the virtual world. Basically, your software lives on the cloud, on their servers, and all you do is interact in terms of sending, well, in your case, actually, video back and forth. But you do put in data. Obviously, I put in the patient's files that they're going to go up to the cloud and be stored there. These are just some of the carriers who actually have big clouds. Google probably, I think, has the largest, but there's Microsoft, which has a huge cloud, Amazon, and these other guys, Rackspace and Salesforce.
I bought a book from Amazon for my Kindle. They did not even give me the option of downloading it to my computer through Kindle. It's virtual. But the only part I hate about that is I always have to have access in order to read my book. But it did not give me the option of downloading my Kindle purchase.
Well, I know I have the same problem, Jerry. So
Yeah.
I think it does. It has downloaded some of my books, but you really don't want it. I mean, on your tablet, you're not really interested in having it.
Well, it's for this class.
Yeah.
And,
Well, that's a PDF. It should download.
oh, shit. Oh, okay.
Yeah. Anything that's PDF should come down. It's whatever proprietary format that
Oh,
Amazon
no,
has.
it's a book, it's a textbook.
Yeah.
Okay, so I can probably save it to my.
So here's another AAS infrastructure, and that's really what it does. A virtual environment provides the clinical user an infrastructure which they have to never think about, never plan, never set up. It's all done for them, and that's really what you want. You want to remove a term that not all of you heard because you weren't here earlier. We talked about was intellectual overhead. My clinical users shouldn't have to know a thing about computers. They really shouldn't, but unfortunately sometimes they do. But in any case, so the ways that healthcare informatics is going is that it's all about trying to remove that intellectual overhead away from the clinician, and good for them. There's a platform as a service. I think actually it's an application as a service. Although the platform could be, maybe we set it up so that Windows 8, maybe we want to have touchscreen and we have a bunch of users who are going to use Windows 8, maybe even on a Mac. Well, you can do that by having this platform as a service where you provide the platform and then whatever apps are there. And it's all because our pipes are so much faster. We have gigabit pipes now. We can put many more people through there. And the servers are so much bigger, and RAM, well, not RAM, but storage is so cheap. And not to embarrass Jerry, but while I'm doing that, let's think about this. This is just a hard drive that you can pass around and look at. This is RAM. This is volatile. This is not, and that's a very important distinction. What that simply means is that 10 seconds, it actually holds it for about 10 seconds. 10 seconds after you shut off your computer, this clears because, of course, if there's no electricity, it won't remember anything. It's empty basically while it's off. Not asleep, by the way, because if you put your computer to sleep, it doesn't actually clear the RAM. This is random access memory, whereas this is storage. This is your hard drive, and it's storage. Now, and this is not volatile. So once you've recorded to this baby and you turn off your machine, the data that you recorded to it stays there, really virtually forever.
Can you explain what you mean by volatile? Do you mean dynamic or?
Volatile means that if you turn off the power, whatever stuff is in there is gone. This isn't volatile, so when you turn it off, the stuff that's in there stays. Volatile versus non-volatile means that if you turn on the power. But just for instance, this is trivial in a way, but just so you know, when you turn off a computer, your RAM stays active for about 10 seconds actually. It doesn't shut off. How in the heck does it do that? Well, look, if you look inside here, and you probably won't be able to see it, there is a little battery there, and you don't realize it looks like a little watch battery.
Yeah, it is.
That little silver guy there. See him? That's your watch battery. It does two things, by the way. So it keeps your memory active for 10 seconds, but what else does it do? Anybody think of anything?
Keeps your clock going.
Exactly. Very good. Very, very good.
It's a watch clock.
It keeps your clock running. So that when you turn it back on, it remembers that it's, by the way, it's, whatever it is right this second. It doesn't have to do that. Now, and again, you would think in a virtual environment, which by the way is exactly what it does in a virtual environment, you can get your time off the cloud. but that's one of the things your battery does. I used to find, and I don't know why it's not true anymore, that a lot of the computers, every once in a while, if you had an old one, you'd have to replace the battery. I don't find that happens anymore. I'm not sure quite why, but it doesn't. So it's not as much of an issue. But just so you realize that, if you have a computer and suddenly it set itself back to 1980 or something, always think about the possibility that it's a clock. And again, I tell you all of these little dumb, trivial things because this is the kind of crazy stuff that can happen to you when you've got a bunch of nurses trying to do their job somewhere and stupid things happen. Like, why is the
Like
clock?
our papers do at 10 o'clock, but yeah.
Well, because, so what does it matter if my computer, I'm a clinician, I'm taking care of people in the ER, what does it matter if my computer clock sets itself back to 1980?
Well, that is a big
Never
time
come
to
true.
Because
Well, because everything is synced to,
date and time stamping.
yeah.
Date and time stamping. The date and time stamping generally runs off of your computer. However, again, if you're in a virtual environment, that's not true. The date and time stamping will be run off the server. And those servers are kept right on time to the second, so you don't have as much of an issue. So probably most of you, if you're Swedish or even UW, I bet you use virtual client a lot, and it's not really an issue, but just be aware
I
of it.
have a question
Can
about
be.
that. I guess I thought the clock was through the internet, because like when you turn it on and it's daylight savings, it automatically.
It
is-
depends on the configuration of your particular machine.
Okay.
You're probably right that in fact is what happens for most computers. Now that's, again, why I don't think the battery is nearly as important as it used to be. Yes, ma'am?
So if we, if Y2K were to happen now, it wouldn't be a big deal. Or would it?
Well, be
It wasn't
careful,
then.
be
I
careful.
mean, it never was a big, it never became a
Well,
big deal.
but we need to, I mean, you're raising an excellent point. Be careful, because, so, does that have anything to do with this battery? No.
No, it wasn't a battery.
No. So what happened in Y2K? What was going on with Y2K? What was the big fuss about? And all these crazy folks who were, oh my God, I'm storing all this food and I'm going to have all this water and
We weren't getting enough digit fields for the torches turn from the 19th century to the 20th century.
Right. In many of these databases and many of the clinical databases, the year was set to double digit and wasn't a 4-digit. And you wouldn't, and you see, here's the thing, Mary kind of raised this issue. You are constantly time and date stamping your data, especially, and again, this was done pretty much at the computer, at the PC level. In those, 15 years ago, it was done at the PC level. So if it couldn't roll over to 2000, because it only had 2 columns, if you will, in the year, you had a serious problem, and it would screw that up. And the software had to be completely rewritten. And here's the thing, you had this legacy software that had been written 10, 20 years ago, and in multiple places in the program where that date and timestamp was called for, because so much is dependent on that in a kind of a database system, that you had serious problems. So it really didn't have anything to do with the batteries. It ended up not being a problem. I know that my boss called me in the middle of, I don't know, the night or day, and oh my God, I'm worried because the nurses are telling me that the EKGs don't have the right time and date stamp on them. And so I said, okay, I'm going to put my consultant hat on again. Don't tell them not to worry. Just tell them to write on the EKG, because they can print it out, put the date and time on there, and we'll be fine. We have the disc. I knew we had the disc. I said, well, Monday morning we'll get it in, and we'll get that software. And they did, and it was no big deal. So, but it was it was just amazing how people got upset and worried and buying all this food and gosh. Okay, so there's multiple AASs, software as a service, and the beauty is that they're scalable. What did we say? What does scalable mean? What's the concept of scalability mean? It's a very important concept in our business.
Change the size or
Yeah, using from small.
Size of what?
The network.
No. It's the number of users who can access the application and be looking at the data all at the same time.
That's right.
That's scalability.
Yeah.
Okay? And again, in a virtual world, in a cloud computing world, it's not a problem. In fact, Microsoft and Amazon, all these, they're very quick to tell you, oh my gosh, we'll only sell you what you need, and if you have twice as number of users, we're going to be good, and we'll only charge you when that kind of load is, and only then. So it's all about that. Okay? And it's accessible from anywhere.
If you have an internet connection.
Well, that's a good point, Jerry. That's exactly right. But here's the thing. Let's think about this, because I think it's a good point to make, a very specific point. I personally believe, and it's actually happening now already, that eventually we're going to, won't be any clinical environment that you work in where you won't have to do two-factor authentication. So we're going to use your fingerprint, for instance, or your retinal scan, for instance, and a password, perhaps, or maybe something else. Maybe a retinal scan and a fingerprint, whatever. So we're going to have to, because single point authentication is simply doesn't cut it. Not at all. It's a mess. People, I've already told that story. So people sit at home in their pajamas and figure out ways to hack in, and they're smarter than I am, and you are, and so the fact is you don't maintain a data center, and we've already talked about that and how important that is. And you don't even know where the data lives. But remember that setting up your data center can cost anywhere between $1 million and $100 million. The VA's data centers, that we have 4 of them, all cost over $100 million a piece. So it ain't cheap. Now, if you buy or rent services like from Amazon, that's a whole other ballgame. But still, it's going to be a lot of money. It still isn't. It's not going to be a couple $100,000. It's still going to be a lot of money over time. But the beauty is you don't have to maintain the software. You don't have to keep it up to date. If something breaks, it's their problem. They have to fix it and keep, get you back online. So just be aware that there can be some significant gotchas. I just recently asked some of my colleagues over at the VA, I said, have you had downtimes? Oh yeah, we've been having them. So you're right, the cloud is a metaphor for the internet, so I actually have to have internet connectivity. And I don't think I showed you this slide yet where we look at what I call multiple points of failure. So in a big complex hospital like Swedish, or like these folks right here, there are so many pieces that have to fit together and have to work together all at the same time. So I can have one piece that's not in any way really related to another piece of the system. And if this breaks, it may bring the whole system down. But here's the other thing that I'm finding is more common. What happens is in a hospital, for whatever reason, well, maybe the router, the UPS, the uninterruptible power supply, in the router closet on a particular ward goes down and starts smoking, and you lose the router. And so those people can't get on, but everybody else can. And here again, in a virtual environment, the doctor can be sitting home in his pajamas writing orders on some poor patient. You're not getting them.
Right.
He can get in the system, but you can't. And you don't see that he just DC'd that medication or started a new medication or changed the dose, all that stuff. And you don't know that.
Yeah.
And so that, from a nursing standpoint, is a nightmare. It's a really bad accident waiting to happen. And so we would always have these debates. Look, are we going to bring the whole system down? Because I could have called the guys and said, okay, turn it off. I could have made that call, but we almost never did because it was just too scary either way. And so I would go around and grab the docs who were there at least and say, hey, be aware of that only part of the system's down.
Well, what happens when the system does come back up? What happens to the providers that were writing orders from home? How does that then reconcile itself? Does it just suddenly all these orders appear?
Basically the answer is yes. That's exactly what happens. The orders appear. You're raising an excellent point, and I think I have a lecture on that in the bucket there for you guys to look at. Because what happens is I have to go in and have the pharmacy not reconfirm.
Review the order, right?
Well, what's the word? Reconcile. Well, that's not the right word.
No.
Anyways, it's having to do with processing those orders. So the pharmacy folks have to process those orders. The problem is, if the nurse did know about them, they may have maybe the doc called and said, go ahead and change that dose or whatever, and the nurse may have already gone ahead and done that, when in fact the pharmacist would have said, wait, stop, the train, that's not going to work for this patient. And so that becomes a really, really big problem.
But that happens even when the system's not down. I mean, that's happened with my students at Swedish, where the student will be getting ready to give a medication, and then, either right after they gave it, the order will pop up.
Yeah, it's in the.
It's like there's a
interval
delay.
between being at the med station, pulling it out, and the doc is changing the
Coming
order.
in, changing it, yeah.
Exactly. It doesn't get routed to the med station.
That's not
So what
safe,
is
they
it?
should not be able
It
to
happens
change
all the time.
orders that close to a
Oh,
med.
but it
But they don't
does.
pay attention to that.
It does
Happens
happen
all the
all the
time.
time,
Well, yeah.
especially at 9 o'clock in the morning.
Right.
Because that's a massive medical error in its system
Well,
sustained.
and this is the whole idea of what we call unintended consequences, because that's exactly the problem, is all these unintended consequences. And I can think of the word, at our place, it was called finishing the order. The pharmacist had to finish the order, just whatever their term they used, where they would look at that and make sure that they thought it was appropriate. So,
I mean, it just poses a lot of challenges in terms of relating virtually versus, face-to-face. Even in a primary care setting, even though we're communicating, via technology, still, I'm aware of the patient, and I can if you have enough foresight as a provider, you're gonna direct your medical assistant to be aware of these particular issues, even when it comes down to prescriptions. But if you haven't had no contact with the provider at all of a sudden you're like, where did this come from? I can definitely see those issues.
and as nursing leaders, you're going to be right nose to nose with this problem when you get out.
It's gonna be a huge problem.
And this isn't going to go away. It's going to, I think, if anything, almost get worse. And so you're going to have to. And here's the other thing. Remember, they're not going to be speaking up for your nurses. You are the one that are going to have to say, wait a minute, stop the show. We need to get this figured out and how to do this properly so that we don't endanger the patient and we don't cause the nurses undue harm. Because you know what they'll do? They'll quit. If you have a system that causes them to make errors like that, they will walk away. They will vote with their feet, and I don't blame them.
I would.
Oh, yeah.
But you can solve it. I mean, I think these are all solvable questions, but everybody has to play well together.
But that's where the breakdown is. Even a good example, of course, is the emergency room at Harborview. I mean, I think providers need a lot of training too. Is having a foresight that when you prescribe, you're going to do it at such a time so there can be awareness on the part of the staff.
And think about it. You're in an ER that's busy, people hanging off the walls, and you're trying to take care of patients. Don't even have time to breathe or potty. I mean, it can be that way. So just.
It just creates this unsafe environment.
Yeah, it does. That's exactly
Legally
right.
as well as.
And so you have to ask, how can we make this environment safe? And I don't have an easy answer for you.
Not easy. Technology is good, but there's a lot of cons.
Okay. All of those things we've talked about.
It's kind of coming and going.
Okay. Here's a number of health websites that I want to just mention to you. One of them that is on here is healthitoutcomes.com. Please write yourself a note to that. That's a wonderful website, especially for you folks who are into quality assurance. Healthitoutcomes.com.
They need to reformat their website though. I mean,
Health IT.
it's so, it looks like a elementary school. Have you know, I mean, am I the only
I
one that
looked
feels
at
that
the
way?
website.
You're not talking about AHRQ, that's what you said last
I'm
time.
talking about health,
Health IT,
health, I use it for my paper, that site.
Yeah, those are just a few of the good websites. Now, this is for the nursing folks, American Nursing Informatics Association, and then AMIA have the American Medical Informatics Association. There are a lot of really good, in fact, many of the pioneers of nursing informatics are very active in AMIA, very active. So those are all good. And then these folks, especially, I mentioned them to you before, especially if you have evaluation issues. And by the way, one of the books that's over at the library is, well, actually, I think there's two books over there that talk about evaluating clinical information systems. So please take advantage of them. Remember, that is part of your final assignment. Now, here's the thing. You don't have to evaluate everything. What I want you to pick is some piece of that puzzle, because you could spend the rest of your life evaluating your clinical information system. But I want you to pick a piece of whatever you're going to do and talk about how you're going to evaluate that in the process of implementing this change. either a new system or a change to an older system. Okay? And these are wonderful, TED.com and TEDMed.com. And then also Ray Kurzweil on YouTube. But TED.com, any of you ever gone to TED.com?
Oh, yeah.
Yeah, they're wonderful. I mean, I'm an addict, I'm a TED addict.
Yeah.
And you know, I'd like to go to the conference, except it's like $3,000 or something, just for the tuition to attend. Never mind your hotel and air.
Yeah.
And it,
$3,000?
yeah, it's more than, I think it's actually more than. And it's in place close this year, though, I think. I don't know where. Amy, by the way, is going to be in San Francisco in the fall, in November. So I'm hoping to get to go to that. Okay, so this is what I wanted to start to kind of show you some things. And you just need to understand, especially in a healthcare environment, this talks about the input devices. And just remember that these are not an all-inclusive list at all. They're just all kinds of other ways, especially in a healthcare environment. There's all kinds of ways we get data into our little computers. You know, a vital sign machine is still a computer. So, and so you have all these different input devices. Output devices, not as many, but certainly similar. Display, some sort of monitor, modem, scanner, printer, storage devices. Now let me just mention too, I don't think I mentioned this before. There's a brand new USB USB format out there called USB-C. And the new Apples have got it on there. The beauty is that there's no up and down anymore. Remember how you always had to get it in the right way? Well, you don't have to do that on these new ones. Plus, it gives you power options, and it just allows for a lot more devices to be attached to your computer. So it's a wonderful change. Right this minute, the brand new Apple guys are the only ones that have it, but it's going to be changing things a lot. It's called USB-C, so just be aware of that. That's coming down the road. Okay. I also mentioned, some of you weren't in here, but the CPU, you can see, well, you can't really see it right there, is right here. But all CPUs are going to have a heat sinks. This is called a heat sink. And what that does is to try to cool that chip down, because when you're pushing electrons through a chip, you use up a lot of energy and you cause a lot of heat. And heat is the #1 public enemy of computers. Used to be dust. This guy is sealed, so there's no dust getting in there. There's not as much of an issue now, but certainly heat is still the issue. So just be aware. I'm just going to put it down so it doesn't fall. Very exciting. Okay. Let's see. So there's a lot of different devices. It's going to be easier if I do it on the screen. These are what's called PCI. That's a personal computer interface. These slots, this is where you put video cards. These slots are actually for your memory modules. And remember now you understand the concept, the difference between volatile and non-volatile memory. And so be careful. This really isn't memory, and I always just encourage people, don't use that term here. This is storage. So if you just remember that, then you're good. So it's your storage. And now,
the old thumb drive. That is now the thumb drive.
well, these guys,
Yeah,
your thumb drives. And now, I mean, you can have, well, I'll show you, I have a slide to show you in a few seconds so you can see the difference. It's just remarkable how much.
So read-only ROM is also volatile.
Ah, good point, yeah. Well, no, I'm sorry. I didn't answer that correctly, Mary. It's my fault. It is not volatile. Read-only memory is generally non-volatile, so information is stored there, and it doesn't go away. That's the point. So that you also see what's called EPROMs, or erasable programmable read-only memory. A CD device is ROM. It's a read-only memory, but it has to be written once at the very beginning of the game, and then that information
right.
is stored there.
That makes sense.
Yeah. So yeah, ROM is not volatile. Now, for some reason,
And the reason for that is because it usually has your hardware operating systems on it. And
Well, it has your BIOS.
Okay.
It has your BIOS. BIOS stands for Binary Input-Output System. And the BIOS is stored on a ROM chip, or actually an EEPROM. And it can be updated, by the way. You can update it. But what it does is it's the basic system that tells the computer how to talk to the disk, how to talk to the printer, how to get the information from the clock, all kinds of stuff. That's what the BIOS does for you, and it can be updated. So there's literally hundreds of thousands of different kinds of chips. And this gives you an idea of what they might look like. In any case, this one is a CPU, but let me show you. So there are many different functions. I mentioned now ROM and EEPROM, and the fact that it contains the BIOS. So here is a CPU, or central processing unit, and it says here 2. Actually, I think that these two pictures don't go together. This isn't a 2. What do you think this is? This is actually a quad core, a 4-core. Now, why do we care? What's going on here?
4 processors.
4 processors, exactly right. However, there's good news and bad news here. For the 4 processor to be of value, the software has to be written so that it will go to multiple chips. I'm sorry, I didn't say that correctly. So it will go to multiple different cores so that it can get its work done faster. So one of the ways, when you think about it, I mean, there's only so many ways we can speed up a chip. Really, we've kind of reached our limit. There are new chips that are coming out that will be even faster, but by and large, with the chips that we have now in silicon, there's only so many slices we can make in that wafer. And as a result, there's some limitation to how fast we can make them go. However, by adding more cores and then by rewriting the code so that the different cores are being used all at the same time, you can imagine how it's like having 2 different people at 2 different ends of the basketball court shooting baskets. Well, because you're doing 2 different things, you could have a higher score if the big game was played that way, which of course it isn't. But that's the point. You're using multiple ways to process the information. That's what makes a difference. I think this little guy is a 2 core, but that still makes a big difference. But I can also promise you that the software is written. Now, one of the main things that they do with that is the video. So if I can process the video on the CPU with very little overhead, and by the way, most people now, especially if they're gamers, any of you guys, gals, got
My son
got
does.
family who are
My
big
son
time
does.
gamers? Well, it's all about their video card. And so what they do is they have tons of RAM on their video cards and really, really fast chips. So it's a GPU, graphic processing unit. So the folks who hack computers, what they've done is they have arrayed a whole bunch of video chips, video processors, together, and that's the fastest computer you can buy. If you're trying to do something very specific, you can use that, if you know what you're doing, to actually hack into systems easier, because then you can put a list of 300,000 passwords in, and it can process that in seconds. So that's why they do it that way. So that's another thing that's done. Anyway, this I think is actually a 4-core, so you can kind of see how they're identical, and that's actually a 4-core. So. And it's just another view of it, and I don't know if you can see through my head or whatever.
I get it. I'm doing well. Oh, I'm really doing good, Dr. Reed, don't worry.
Okay, so there's a SIM. And the SIM simply means for Serial Inline Module, SIM, or Serial Inline Memory Module, SIM, S-I-M-M. They used to have the DIMMs, and those are Dynamic Inline Memory Module. So that's just those words. These little cards, this little guy that you're all familiar with, these are SDs, or the mini SDs, and that is just, it's actually SSD, and it's, I know all these things, and I'm...
Do we have SMCs or MMCs?
Yeah, we do.
They're letters.
It'll
and
come
they're
to
stories.
Alphabet soup.
Exactly. Alphabet
Oh, it
soup.
is alphabet soup, absolutely.
And it's
By the way,
good
do you
stuff.
see how I took the white away there, but it does, it sometimes does that, it kind of pixelates some of it. So that's, Okay, so there it shows you how to put the
Previous-
SIMs in, new SIMs. The thing about is that somebody, I think one of you were talking to me about the fact that your Macs don't often allow you to put additional RAM in. I used to tell, well, it's on this slide that's coming up, that that's one way to dramatically increase your speed is to put more RAM or additional RAM in there. So.
Right, but Mac uses it as a marketing. I mean, that's part of their budget, you know what I'm saying, it's their strategic plan to make you have to buy a new
Yeah.
device.
Well, there's also planned obsolescence. I mean,
Yeah.
the car industry does that. You know, they don't want your car to last more than 50,000 miles. Then you got to come and buy a new one.
Once you buy a new one.
So just what I said here, remember that modules are static, or they're very sensitive to static. I don't think that's as true as it used to be, but you still want to be careful. And what you want to do is, I mean, some people will say you should unplug your computer before you change the SIMs. I don't like to do that. I leave it plugged in, and I just put my hand right here a couple times actually, like that, just so that I discharge any static. Not so much that I'll save the SIM. What I want to save is my butt. I don't want to get electrocuted. So if I do it that way, then if there's a problem, it'll show me right away. I prefer not to get electrocuted. Okay, so ground yourself before touching the modules. Watch when you take them out, and this is an important one. So watch when you take them out so you know how to put them back, and make sure that each module is seated and the clips are locked. There's little clips on the side here. If you looked inside this box, you could see it. There's these little clips, and those.
Fancy
Yeah.
one, that has 4 SIM cards, most of them only had 2.
Well, no, most have.
Well,
at least
the
4.
old one I had,
Oh, okay.
I had a Hewlett Packard, and it only
Mhm.
had 2 slots. Like,
Fair enough.
like 2.
Yeah, so the bad news of that is, well, actually your laptops are that way. They only have 2 slots, so you have to throw away, if you will, your old SIMs and put in new SIMs, but you can't just use both of them. So the newer computers, you can, still a mess. What we find now is with the newer operating systems, they'll find your RAM. Used to be I had to tell the RAM that, by the way, I have more memory now, but you don't do that anymore.
So these seem, I mean, are you still replacing your memory? Are you still changing it? It seems like these days we really aren't doing that
No,
anymore.
you're not doing it
We used to have to do it every year, every 6
You know
or
what,
9 months.
I have 2 tools that I want to recommend to you that I don't really mention. And one is called Norton, the Symantec Norton antivirus, because it has a whole PC tuner built in, and what it does is it tunes your registry. So let's just talk about this, but I want to come back to that. And also a thing called System Tools. If you have a PC, I don't know if there's a version for the Mac, but my gosh, System Tools is amazing, and it keeps your system up to, it keeps it from getting so old. So anyway, that just shows you what it looks like inside. They all have similar pieces. There's a hard drive right there if you want to look at one. And I remember that my first hard drive on a PC at the college where I was teaching at was 10 megabytes, and we thought that was amazing. We just thought that was incredible, 10 megabytes. And now now you can buy a drive. Last I've seen them was 3 and even 4 terabytes. So, and I remember, it's been a few years ago now, but our guys were telling me that the patient data file from 50,000 patients was about 5 terabytes. So, and those drives that we used to use for that purpose for, I don't know, $10,000 a piece. Now you can buy a 3 terabyte drive for $100. I mean, it's just unbelievable how cheap stuff has gotten. And I will tell you, it's interesting because about, 12 years ago, there was a fire at a memory plant in Japan. And they apparently were one of the big memory module builders for the whole world. And so suddenly RAM went just through the roof in cost. So I always had this policy when I would go visit friends around the country. I'd go out and buy them more RAM just as a way to pay them back and put it in for them. Well, you couldn't, it was just, you couldn't afford it. So anyway, that's not true. But RAM and hard drive space has come down so very much. And that's kind of Moore's Law. Moore's Law says that basically every 2 years, I think, that the cost will go by half, will decrease by half, and the amount you can get will increase by twice, by 2 times at least. So they use that. That's actually not quite the way Moore meant that law, but in fact, that's how it's used a lot. Anyway, these are non-volatile, so you remember that. I talked about the memory sticks, known by many names. I remember the first one I had 64K, and now I've seen 64 gigabytes on one little memory stick. It's just incredible. Very easy to lose. My wife, she runs the student affairs office at Seattle, and she said, you know, they get 2 or 3 of these a week at least, not more, that people leave these, lose these, whatever, and are looking for their drives. And I mentioned to some of you weren't here, or not all of you here, there's a really interesting, fun movie called Johnny Mnemonic that Keanu Reeves is in, where they put one of those little sticks in your brain, and that's that way they transport information. So it's an old film, but it's kind of fun.
They had a memory week, I believe, also.
Yeah. So this just shows you all these, and now your phones have this little guy. My cell phone has one little guy like that, and I think, yeah, I have 32 or 64, I don't know how many, gigabyte, not just megabyte, but gigabyte. That's a hell of a lot of information in a pretty small space. In addition, we have solid-state drives, SSDs, solid-state drives. And now I think actually in the not-distant future, we're not going to have moving parts anymore. We'll have the only moving part of your computer will be your on-off switch. You'll have solid-state drives. The nice thing is they don't heat up as much. They're very durable, and they're non-volatile. So 256, your operating system, I mean, and I don't know about the Mac, I'm not sure, but I would say your operating system is generally not going to consume more than about 2 gigabytes. So you've got another 250 gigabytes for everything else. That's a lot of space. So a movie on a DVD is about 3.5 gigabytes. Remember, the old CD-ROMs only hold 650 megabytes, but with the DVDs, the ones with the Blu-rays, those are actually what we call double layers. So information is stacked upon. It's not just distributed, but it's also stacked. And so that's where you get 3.4 gigabytes on one DVD. So those just show you all the different. This little guy here is actually for a PC or a laptop.
I have a question, I'm not
Yes, sir.
sure.
Let me just say this, but hang on to your question. And that's another thing that we see now is that what companies are doing is they're distributing their software. This is actually a game, but they're distributing their software on
Right.
SIM cards, or not SIM cards, but little SSD, solid state drives. So go ahead, Jerry.
This is probably about 5 to 10 years old, but there was a time when they were selling both the solid state drive with like 25, especially like 100 to 200 gigabytes on solid state. Then you had a regular hard drive. Do you know what that was, why they had the 2 different ones there, or?
Well, because the other one's portable. So if you have it on some sort of a little removable drive, then I can pull that out. I use this a lot. What I shouldn't have to, but I get a lot of stuff where it's faxed to me, and then I will take it off my computer, put it into my printer, and it will fax it for me. So it's all about having something removable. And so here's the other thing: is that usually on your drive here, you'll have the operating system, you'll have the application, but the data, your patient data, your whatever data, will be on one of these guys. And so that's another thing to do. Okay. So are these guys computers? What do you think? So before you answer the question, let's frame it.
There's more information.
Okay, so let's frame it in terms of the kinds of questions. Does it have input devices?
Yes.
Does it have an output device?
Yes.
Does it process information?
Yes.
Will it store information?
Mhm.
Some of
Yeah.
them won't, but that doesn't mean they're not computers. But they do a lot of the same things that computers do. And so clearly, all of these have some computational capacity. And do you think that the design of this and the size and color and all that are accidental?
Probably not.
No. They've done a lot of user research to find out just exactly, because here's the thing, I remember, again, so vividly, the nurses were saying to me, Michael, I can't, my eyes are too old, I can't read the medication screen to see what's due. My medication's due list, I can't see my due list. The font's too small. And so we had to go back and say, hey folks, you're gonna have to fix this so that the font could be bigger. And so that's something that had to be done. And this is not an accident at all. Even all these buttons and the naming, everything, so they had to do user research to find out what works and what doesn't for users. Now, is that color a problem? Well, it sure is for some people who are colorblind. Very interesting. I stumble on a lot of things, but I was looking at stuff yesterday, and there's a new pair of glasses that, who designed these? I forget. Some big glass company designed them. And they look like just plain old sunglasses. They're just like this. They look like sunglasses. And it was a short video, but had a number of people who were colorblind. And the thing I didn't know is that if you're colorblind, it doesn't just mean you can't see red. There may be other colors that you can't see. But anyway, this pair of glasses was curing it. And these guys, for the first time, two young ladies and an older guy, were like seeing, and what they had was kind of a rainbow thing that they had set up of yarn. They used yarn and set up kind of a rainbow thing. And there were tears. And they said, I had no idea how little color I saw. Everything was just sort of gray, drab, whatever. And now they can see colors. So it's pretty amazing. But that red, I'm a little surprised they're using that. Normally you would think that would be white, because you're not as likely to have a colorblind person is not as likely to have an issue with that.
Well, when you're colorblind, you can still see it, you just can't see it in the color of red, right? So
Generally.
they might see it in the color of gray.
Good point, Mary, but here's what you may lose, and that is contrast. In other words, one of the ways that you see things is that it's contrasted with other colors around it. That's why I put a light blue on top of a pink background, because there's a nice contrast there. If you ever, if you play with it a little bit, go to a PowerPoint slide and start playing around and putting different colors, you'll find that it makes a difference. For instance, this is trivial, but in church, when we would do this, I do the slides for the songs, I always had to put a border around the letters. Fairly easy to do, it's just a little shadow thing. But that way it created a greater contrast so that everybody could see those letters and read them well. So.
Because I can see the 199 on that white background, even though it's a worse color, but it's easier to see it than it is the red on the black background.
Right. And of course that size of that font is real critical. Yep. But remember, you've got nurses, the average age of nurses is about 47 years old.
Only 42.
Huh?
Only 42.
Face.
What?
So all of these devices have an input capability and a user interface. So that's your user interface. And so one of the things that you're going to be tasked with is you're going to be asked to help plan that and think about that, and as you buy new equipment. And it's not a trivial matter. It's a very, very important matter. So you need to get some of your youngest nurses and some of your oldest nurses to look at it and say, will this work for you? Or if it won't, what could we do to make a difference that would work?
In the book there was a really interesting job called a human factors engineer that looks at working with people to help work through some of those problems just like that. I never heard of that before.
We do it a lot. In fact, you know that for devices and stuff, like especially programming infusions, we've learned about trailing zeros versus leading zeros, right? So anything that has a decimal point, unless it's a number other than 0, you do not show that number, because it could look like you can make an error in factor.
Correct. Yeah.
Whereas if it's a number before decimal point, it's either a 0 or there's a number, but you don't leave it empty, because the human eye can only perceive so much, and you can really make a lot of errors of magnitude of 10 or something if you don't get it right. So all of the devices now use trailing zeros and leading zeros.
That's a great point, Joan. Yeah. So binary is a language of computers. I don't see that changing anytime soon, although I could be wrong. But assembler is the language that it's converted into right before it actually converts to binary. So you actually have two, what we call compilers. And a compiler takes the language of the code, changes it into assembler, which is machine code, which then changes it into binary. And that's how it actually does its work. Everything is binary, which is O's and zeros. We'll show you that in a sec. COBOL, Fortran, two of your oldest languages. C, C++, and C# are the languages that most applications are written in. Epic is written, I don't know which one, but it's written in one of the C languages. I think C++ is Epic. Visual Basic and Visual Basic are two of the languages that are actually fairly commonly used, especially for small applications. But anyway, that's another one that's used. That's Bill's language. That's the one he bought from IBM for almost nothing and turned around and sold it for gazillions of dollars. Now, HTML is really not a code. It's really not a language. It's a rendering language, and so it's different. What HTML does, hypertext markup language, what HTML does is it tells your computer, your browser, if you will, how to display information. That's what it did. It's rendering it. It's taking the word, your name perhaps, and making it big or small or blue or green or with a border of some kind, whatever. It's a rendering language. It renders the data in ways that are meaningful, HTML. XML, by contrast, is the data language. So XML is extensible markup language, XML. And the reason I make a big point of that is this, is that so much data in many of your systems is written in, or the data is stored in that XML because it can be user defined. So the system can define all kinds of things and make it easier. And so that data, and you can do it very hierarchically. So it's one way to store information, especially for patient data. It's very commonly used, and actually a lot of different disciplines use it, XML. But it's also the language of the web. I mean, it very much works well when you're trying to render it. And then they use so they have XML and they have XSLT, which is extensible. It's the language that actually tells how big to make the font and what color and all that stuff is your XSLT. And I'm sorry, I can't. Forgotten all my abbreviations. I don't remember that one. ASPX is application, so application server program, or ASPX is more. And here's what happened. When the web first started being used back in the early 90s, you basically went to the World Health Organization website and you could look at their documents. And there wasn't much fancy there. But in time, we started to have more interactivity, and we wanted to be able to go onto a website and enter our name and our address and our whatever, and we want to buy this, and here's my credit card. Well, all of that then required interactivity, and that's why we needed application server programming languages and ASP. So web pages, instead of being HTML or HTM, they had to be ASP, which allowed them to be very interactive, so that you could interact with your web browser, and that's where that's come from. So the program that I'm working on right now with the feds is written it's like that. It's written in ASP because it's very, very interactive. I mentioned a compiler a few seconds ago. A compiler takes the code and changes it into something that the machine can process. That's all it is. It's just a term that's used. It's called a compiler. And there's languages that are compiled, if you will, into binary or into assembler, and then fed into the machine, and the machine does whatever processing it needs. Or what we call just-in-time, JIT language, GIT, just-in-time. And what that means is, for instance, Visual Basic is kind of a just-in-time language. So it does it right at the time of processing. Now that used to be a problem because it would slow things down. Not anymore. You've got machines that are more than one core. They're very fast. The pipes in your computer are fast, and so it doesn't really slow things down. And the just-in-time language doesn't create a big problem. Okay, so here's some assembler code. It gets it from many different coding languages, COBOL, Fortran, whatever, C, all they start out with their own language, and it ends up looking something like this. And then it's all the code then is turned into what we call assembler or assembly, and then it's into binary for actual execution by the chip. Okay, so it's dependent on this, and this is like, what does it all mean? Well, it's all about bits and bytes. I said that a few seconds ago. Everything in your computer is a 0 and a 1, basically. It all boils down to that. So what you have is bits, and this is what's called an 8-bit word, or a byte. And so a capital A is going to be 0, 1, 5 zeros, or 6 zeros, and then a 1. Okay, so that just happens to be the binary code for a capital A. But these are all the characters. And actually there are more, but in any case, these are all there's your special characters, obviously your numbers, more special characters, your capitals, a few more special characters, your lowercase, and a few more special characters. So that's the complete character set. Now, what if you're in an era of speaking? Well, then they have obviously a different character set. What if they're doing kanji? How many words are there, or letters are there in kanji? 3,500, something like that. So it's very different in terms of this, but for English, this is what it looks like. So 1 bit is 1 on or off position. A byte is 8 bits. And a byte can be any one of 256 possible combinations of zeros and ones. And numbers that are written with just 0 and 1 are called binary numbers. So every input is converted into digital data string of zeros and ones. Before I go to that, just one of the things I'll show you. Well, I'll wait and show you the header because then it'll make sense. Okay. So can we convert an EKG into binary? Well, we have to, because EKGs are stored as digital data, and so are the images? Well, in a way, but not really. So, so there's the question. And so here's how we do it: amplitude versus direction. So that data is stored for every versus time, and so tracings are computer interpreted and loaded into the chart for immediate clinical access. Now, what happens in most ICUs, for instance, is the computer then is actually, the EKG is then sent to some place in, I think Chicago is where they do a lot of this, but that's not necessarily, doesn't really matter, where it can be interpreted. It doesn't have to be done locally, it's interpreted. And so you get a basic reading. Then most ICUs, the attending cardiologist will review these within usually 24 or 48 hours, and then put their interpretation in, and they can agree with whatever the computer said, or they can disagree. And my experience was that at least half the time they disagree. It's very interesting to me to see that about half the time. In any case, they then go in, they have ways to go into the computer, change the interpretation to what they believe it is, and then sign off on it. And that's why it's important. If you look at an EKG, you'll often see if it's gone into the computer system, it will say there verified or unverified, or interpreted or uninterpreted. And so that would be what that means, is that it hasn't been read by a human being.
I guess I don't really see the point. It's kind of late after 24 hours for it to be reversed. I mean, as a medical part of medical record, yes, but actionable, it's not really actionable anymore.
Yeah, and that's a good point. And Jody, check me out on that. You might just ask around as far as how your stuff is done. It may be slightly different. And I could see in an SICU, or I'm sorry, an MICU, maybe they do get this stuff looked at quicker. I'm not sure. Sure. So, yeah, it'd be a good question to ask somebody. Okay. So you begin to see how they can fairly easily convert this into digital data and then store the information. I thought one of the things that might be helpful to you is just to get a sense of all these crazy names we have. So a bit equals 1 bit. Right? A byte is 8 bits. We've already showed you what that might look like. A kilobyte is actually 1,024 bytes. A megabyte is 1,000 kilobytes. So you just keep going up. A gigabyte is 1,000 megabytes. So a gigabyte is really a gigabyte would be a better phrase, but that didn't make sense, so they changed it to gigabyte.
And did you say that one character, the character A, requires
8
characters?
Okay, be careful. In some systems and in some programming scenarios, it's a 4. They'll use only 4 bits to make a character. Generally, it's 8. So. not everybody uses an 8-bit.
But if it takes 4 characters to create one letter,
Yeah.
and you then would divide 8 into 1024, or
Okay.
4 into 1024, is that the way is that what you're,
Oh, well, no,
is
it's,
that what this is implying then?
well, no. When I look at a kilobyte, it is 1,000 bytes. In other words, it's 8,000 characters, or 8,000 common bits. It's 8,000 bits. Okay?
Right. Oh, 8,000 bits.
Yeah.
8,000 bits.
Would be a kilobyte.
What's 1,000?
Because a byte is actually 8 ones and zeros together in an array.
Oh, right, it's 1,024 bytes, not bits. Got it.
Yes, that's right. This is confusing, and don't feel bad if you don't,
Oh, I know.
have it figured out, because it is confusing. So a terabyte, I mean, it's amazing. Just a few years ago, we started giving your own terabyte drives, and they're not even $50 in them, for heaven's sakes. I thought, wow, I just remember so well when our guys were telling me that our whole patient data set was about 5 terabytes.
So probably the upper limit hasn't even been named yet then?
No, that's correct. But see, here's the thing.
So
You're not
infinity
gonna
and
have- You're not going to have all of this information in one single file.
Yeah.
So if I have that much data, it's going to be in separate files. That's one of the things that's true about Vista, the heart of the languages. What they do is they actually put the data in multiple files, or what they call globals. It's just a funny word they use, but it really means the same thing as a file. There's over 8,000 different files in the back end, if you will, of Vista, which is the largest health database in the world. I mean, it keeps track of everything. It keeps track of all your providers, all their demographic information, all of your patients, all their demographics, as well as all of their clinical data. 8,000, more than 8,000 different files. That grows all the time too, because they're always creating new files, because we have new different technologies that capture different data and do it different ways, and so it's constantly growing. But I thought it'd be fun to see the yottabyte. That's the largest we've got so far. I don't know if there's any file out there or system, but here's the other thing. So yes, I said to you that we'll never have a yottabyte file that big, but we might have yottabyte drives. However, think about this. Even given that, I don't think anybody's going to want to put that information in one drive.
No.
It's too damn much, and it's just too scary.
Oh, never say never. Gosh.
Yeah,
Would have never thought of a terabyte or a
Yeah.
gigabyte.
yeah. And here's the other thing.
Huh.
One of the things that you'll see that if you talk to your network people, they'll talk about RAIDs, RAID array. And what that means is they have multiple hard drives that are in an array, so that the data is stored probably on 2 different drives at the same time, so that this drive goes belly up, then I've still got the data on this drive. Okay. Now, in the cloud, again, it doesn't matter, but that's actually something the guys and gals in the cloud do too. They array their stuff on RAIDs, big arrays, and they have it on more than one drive at a time, so that I never, the chances of both drives going down are pretty slim. Okay.
It'd be interesting to study the development of the computers based on the male or female perspective.
Oh,
Oh yeah,
that's a question.
I walked into a store one time when I was probably 12 years old, and I said to the guy there, and I said, well, how come that's a female plug? I said, what is that? How did you do that? And this wonderful old guy, he was just the sweetest guy in the world, he said, I don't know, he said, you see that? What does it look like?
Oh,
It was a male plug, and I said, oh. And they go, oh, okay, thank you, I got it. But I was a kid, and I thought, male, female, what does that mean? So, yeah. So we were talking about museums. There's a museum at RePC, but there's also, which is just down on 6th Avenue, wherever I should be pointing, I don't know. But there's also a museum that's right on 1st Avenue there. Is that 1st Avenue? Yeah, it is, 1st Avenue South. Yeah, 1st Avenue South before you get on to 99, not 99, but the West Seattle Bridge. So go in there and look, it's just amazing. And actually Microsoft has a fun museum too out there interesting. See, there's a number of them. It's just
Can I ask you a
amazing where
question?
we've
It's kind
come
of off
from.
the topic,
Yeah.
but maybe it's a bit too off the topic. But, so the movie Imitation Game, you know how how he was decoding in terms of the connection to discovering or decoding the Enigma?
Oh, yeah, the Enigma.
So
I haven't seen
how-
that. I'd love to.
Oh, you have to see that.
It's a very.
It's fascinating, but maybe, well, if you haven't seen it, maybe you won't be able to connect, but it's just kind of interesting how the machinery of what he did,
It's really
how it
chemical.
translates to current day,
Yeah.
like the bits and the bytes. I don't have the brain to try to figure out the mechanics of all that and how that translates to, you know, AI and all these other things. Do you have any, do you know, I'm assuming you know the history there of
Yeah, I do. Yeah.
yeah, but it's kind of interesting. I mean, taking that from he was, you know, the first primary inventor of the computer. I'm just like, okay.
Well, you know, the interesting thing is,
Yeah,
I
it's
didn't find his
fascinating.
name anywhere.
No.
Alan Turing, like in the textbooks that we read.
Mm-mm. No, I haven't
Turing
read on the
or-
computer.
Yeah,
Have you
Turing,
seen
they don't
movies?
mention him. I mean,
Yeah, that's
he's
true.
credited with
Alan
like,
Turing.
you know,
No, the
being one of
movie.
the first
Imitation
inventors of
Game.
computers. But our textbooks don't really mention him.
Well, like Pascal was one of the languages that really isn't used much, but it's a precursor to C.
Okay.
And Pascal was a monk back in the 1800s or something, and he was kind of a mathematician. He posited a number of the theories that helped us figure out what to do with computers. So,
Well, maybe if you see the movie, you can.
Yeah, why don't you see
Yeah.
the movie
If you
and
could
come
think of the
back?
movie,
I will.
Get back
No,
to
that's going to be my homework.
Imitation.
I would love to
And then
hear
tell
your
us about what's
processing.
Yeah.
happening with
How
all
he
those
just-
dials
how they
and
just-
the-
yeah.
It's Johnny Mnemonic.
Okay, Johnny
and he's
Mnemonic.
gonna watch the
Okay,
Enigma
Johnny
Code.
Mnemonic. You and I
It's
will.
Keanu Reeves. Keanu Reeves, Johnny Mnemonic. So look, where are we supposed to, this is terrible.
I thought it was 220, is it?